This is Manisha Mane, Assistant Professor from Shahan and Karkachi Engineering College. As a task of International FTP on Environment and Sustainability, here I am presenting Week 4 video on the subject Carbon Footprint of Mobile. In Week 1, we talk about effect of mobile radiation on environment. So here, mobile radiations are majorly affecting on human health in terms of headache, then sleep disorder, or it may cause cancer. When we are talking about effect of mobile radiation on insect, bird, and animals, it has been observed that these are facing with the problem of infertility. When we are talking about plants, then it is observed that some plants are dying when the cell tower is near to the field. In week 2, we talk about mobile communication and ISO standards. So what are the ISO standards which are related with the mobile communication we discussed in week 2 video. The video outcome of this activity, after learning through the video, students will able to analyze the use of mobile phone which leads to carbon emission and hence environmental losses. Second learning outcome is classify the application which create carbon emission and their percentage. Then third learning outcome is apply the knowledge of carbon footprint that will try to reduce the use of mobile phone which leads to sustainable development. Sustainability, computation and standards. So here we have selected few standards which are related with mobile communication. ISO 9000 which provides a basic outline for management system and sets of scalable best practices that businesses can use to meet customer requirement and improve operational efficiency. ISO 14001, it is for effective environmental management system and for sustainable development. Then TR 9000 is improve on framework set by ISO 14001 and to create a more effective management protocol that are fitted to the demand of the industry. ANSI/ESD S20.20, it focuses on electronic component in the communication space and set up control to protect the devices from damaging electrostatic discharges. OHSAS 18001/ISO 45001, it is ISO's quality management system for occupational health and safety. ISO 50001, it is one of the most important electronic system standard as it deals exclusively with energy management. ISO 27001 is international standard for information security management. So these standards take care of users' intellectual property. So if you see the definition of carbon footprint, it is amount of greenhouse gases, primarily carbon dioxide, released into atmosphere by a particular human activity. So if you see the total carbon footprint distribution, then you will find that 33% is the contribution of electricity, 35% is for travel, 5% emission is by food, 8% is waste, cooking fuel contribute 4%, whereas cell phone contribute 15%. Now, carbon footprint of the mobile phone will be depend on the life cycle of the mobile. So it starts from the material extraction, then manufacturing, packaging, then transportation, useful life, then end of life. It may go to the recycle or it may go to the disposal. So here I am going to consider a useful life as a case study. So increase in the mobile phone user leads to increased emission of CO2 in the atmosphere and it leads to a global warming. So, if you see the use of the mobile phone, then application using creates 21% carbon emission, charging creates 18%, calling creates 5%, texting 54%, Bluetooth using 2%. So this is the distribution of carbon footprint for the model of the mobile phone. So this data is taken by the study of the university students. So carbon footprint for mobile, how much carbon footprint from the use of mobile phone gather on the number of the hours mobile phone use, following parameters are used. So the parameters are texting, application using, charging, calling and Bluetooth using. So the calculation of carbon footprint per day is as follows. For texting, it is 17.95 kg CO2 emission takes place. For application using, it is 7.06 kg CO2 emission takes place. For charging, it is 6.10 kg CO2 emission takes place. For calling, it is 1.78 kg CO2 emission takes place. And for Bluetooth using, 0.49 kg CO2 emission takes place. So average, it is 33.38 kg CO2 emission takes place daily. So texting contribute most of the carbon footprint emission by mobile phone use. This means that students keep on texting while is usually done at the average of 5.25 hours per day. When the frequency is taken into a yearly basis, texting would produce 6.55 tons of CO2 emission in the atmosphere. Students use their mobile phone through application using for 2.05 hours daily. Mobile application using will create 2.58 tons CO2 annually. Applications using are footprint coming from the charging and calling, which are done by the students for 1.78 hours and 29 minutes per day respectively. Overcharging could waste the energy, giving off 30% more CO2 emission than the optimal charging, and calling contribute a total of 2.88 tons CO2. A footprint value small in the environment sense, but great area of improvement in education for sustainable use and social affairs. The total annual carbon emission from the mobile phone use produce around 8,47,193.08 kg CO2 emission, or about 84.71 tons or equivalent. This may be a tiny portion of the global emission, but if a person is using their mobile phone every hour, if they can add up to a 1 ton CO2 emission per year, and it may exceed 2 depending on more use of mobile phone. To achieve sustainability, minimum use of mobile phone is recommended. This is all about this video.